So we will solve one or two problems on force systems. This is an examination problem, first problem. VTU examination paper, February 2022. A person is pulling an inclined pole ABC with a rope BD as shown in the figure. So this is ABC is the pole, this is the pole, and a rope is attached at B to this pole, and a person is pulling this in the direction BC, which is making an angle of 30 degrees with the pole, and the full force in the rope is 400 Newton. He has given that the pulling force is 400 Newton. What he has asked is find the rotational effect felt at point A. So what is the rotational effect of this 400 Newton force at the point A, and also the push force felt along the pole direction. That means due to this tension force on the pull force in the rope, there develops a push force. In the push force will be, I can show like this. This is how the push force will develop. So push force is developed like this. So we have to find out something. Not like this. The push force is like this. Towards the joint we have to take, towards the point. So this is the push force which can be expected in the pole. Now, here, the thing here is, what is this push force? This we have to calculate. So I will call this as push force as F. So there are two things asked in this problem. One is the rotational effect of this 400 Newton force about the point A. So rotational effect means it is nothing but the moment. The moment of the force about the point A. So first part, rotational effect at point A. So it is given by the moment about B. That's all. Moment of that 400 Newton force about A. Now to calculate the moment, we need to resolve that force. So this is 80 degrees. There is one point A is here. This is point B, where the force is acting like this. 400 Newton force is acting away from B, and this is 30 degrees as given. So let me resolve this force into two components, horizontally and vertically. So like this. So these are the two components. So since this is 80 degree, this total will be 80 degree. Therefore, this will be 50 degree. So this force becomes now 400 cos 50. Because that is the adjacent angle, and this is 400 sin 50. Now moment is obtained by multiplying the magnitude of the force by the corresponding vertical distance of the lever arm or the moment arm. So this force is acting at this distance, whereas this force is acting at this distance. So these two distances we have to find out. That can be found out by using this triangle. So he has given that the distance AB. Distance AB is 2 meters. Now this is the right angle triangle wherein if you want this, now you take this as BE. So BE is this value. So it is obtained by taking sine ratio, because sine 80 is equal to BE divided by hypotenuse, that is 2 meters. Therefore this will be equal to 2 into sine 80. 2 into sine 80 degree, whereas this distance will be 2 into cos 80. That is from the trigonometry. Now we can calculate the moment about the point A. So I will have to take moment due to this horizontal component as well as due to vertical component. Due to horizontal component is clockwise, due to vertical component is anti-clockwise about the point A. So I will use sign convention, clockwise positive, anti-clockwise negative. So if I use that, then this becomes 400 cos 50. It is a clockwise moment. Multiplied by the distance is 2 sin 80. 2 sin 80 degrees. Minus, because this is giving anti-clockwise moment. Force is 400 sin 50. Multiplied by distance of the line of action of this force from A is 2 cos 80. So this is the rotational effect of the 400 Newton force. If you simplify this, you are going to get the value in Newton meter. So based on the sign, we can decide whether it is clockwise or anti-clockwise. Now let me simplify that. 400 into 2 is 800. 800 into cos 50 into sin 80. So that is the first value. You are going to get 506.42 minus, I will take 400 into 2 into sin 50 into cos 80. So if you deduct that, you are going to get exact 400. So 400 Newton meter is the moment. Since you are getting positive value, this is clockwise. That means the rotational effect of this 400 Newton force about the point A is a clockwise moment of 400 Newton meter. That is the first part of the problem. Now the second part, we have to compute the compressive force or the push force which is going to develop in this hole. So for that, what I do here is I will take this BC portion BC, which is having 1 meter length, and in this BC portion, as I already told, there will be a compressive force of F, or the push force of F. Then I will take this tension force already which is existing in the rope. So this angle is 30 degrees. Now what I have to do is, using the equilibrium equation or the condition, so this I know that this is 50 degrees and this is 80 degrees. That is given in the problem. Now what we have to do here is, I have to resolve these forces to apply the equilibrium equation. This is the case of a concurrent force system, where we can use two equations, sigma Fx0 and sigma Fy0. Since here we have only one unknown, that is F, we can use only one equation among these two. So for that we need to resolve these two forces. Let me resolve this 400 Newton force. Horizontal component is like this, vertical is like this. Horizontal component is 400 cos 50, vertical component is 400 sin 50. Whereas here if you resolve, this is the horizontal component, this is the vertical component. So vertical component is F sin 80, whereas horizontal component is F cos 80. Now either you can use this equation or this equation to get the unknown F value. So let me use this sigma Fx is equal to 0, treating the forces acting towards right positive, left negative. Only two forces are there. This 400 cos 50 is positive, F cos 80 is negative. So I can use that condition now. So if I use the sigma Fx is equal to 0 for this 3-point diagram of the joint B, so I can write this as 400 cos 50 minus F cos 80 is equal to 0. So therefore F is equal to, that is the push force. This is the push force in the pole. So F is equal to, so 400 into cos 50 divided by cos 80. So the answer is 1480.67. 1480.67 newtons. So this is the push force in the cable. You can use the second equation also. Sigma Fy is equal to 0. If you use the second equation, what you have to do here is 400 sin 50 should be equal to F sin 80. So I think then also you are going to get the same answer. So let me check that. So F will be equal to 400 sin 50, 400 into sin 50 divided by sin 80. So you should get the same answer. 311.144. 400 cos 50 is equal to F cos 80. F sin 80 is equal to, so I will sin 50 400 cos 50 minus cos 80. So here 400 sin 50. Okay, I will take only this equation. Sigma Fx is equal to 0 equation. So you will get the answer as 1480.67 1480.67. 1480.67. That is the push force in the pole AC or ABC, you can say. So this is how we have to do the problem. To get the push force, we need to apply the equilibrium equation at the joint B. So BC, you can get the push force. So this is how we can solve the problem. So if we are getting once again I will check. Cos 50 divided by 400 into cos 50 divided by cos 80. Yeah, it is 1480. 1480 divided by yes. This is how we have to do the problem.